Of prisms and cylinders. Today we'll cover volume of pyramids and cones. A lot of similarities between the formulas, so let's talk about the formula on the front, then we'll do some examples on the back. Now, remember we're talking about volume, so we're still doing cubic units like inches cubed, feet cubed, etc. There is a generic volume formula. They will give this to you on the EOC. They won't tell you what shape or shapes it goes with. So I'll just give you it as one of the volume formulas. Now, you'll see that it's almost the same thing as the volume formula for prisms and cylinders yesterday, except you have the 1/3 coefficient in front. Okay, so that's the only difference. So the volume of pyramids and cones, here is your generic volume formula. It's 1/3 BH. 1/3 times the area of the base times the height. So you basically do area of the base times the height like yesterday, but you have to divide it by 3 or take 1/3 of it. Now, when you take 1/3 of something, you can divide it by 3. You can also multiply it by the decimal form. Now, 1/3 is 0.3 repeating. If instead of dividing by 3, you're going to multiply it by the decimal, you need to use many, many 3s for accuracy. So if you're going to multiply it by a 0.3, I would use at least 3 or 4 3s, okay? So whichever way you want to find 1/3, you've got to find it somewhere along the way in the formula, all right? And guys, a lot of times, maybe the B value or the H value, when you take 1/3 of it, can be a whole number. So you can take 1/3 of either one of these, or just take 1/3 at the end after you multiply B times H. It doesn't matter when you take 1/3. All right, now, a couple things. It's a normal height. Remember, even though pyramids and cones have slant heights, that is for surface area, not volume. So you're using a normal height, okay? Usually kind of an imaginary height going on the inside of the shape, okay? And then remember, it's not always straight up and down. If the cone's lying on its side like a megaphone, the height might be going horizontal, okay? But remember, the main thing about the height, it's perpendicular to the base. So it makes 90 degrees with the base, all right? And guys, the height might be called the altitude. That's another name, a synonym. Height, also known as altitude. So if they say the altitude of the cone or pyramid is this, they mean the height of it. So you put that in for H, all right? But 90 degrees with the base for your height. All right, so there's your generic formula. Cones, same generic formula. Just make sure, remember that in place of B, you're pretty much using pi r squared because the base is a circle. So you're going to have to do pi r squared when you go for the capital B value for the cone, don't forget. And guys, remember, if you look at the cone, even for pyramids sometimes, you've got a right triangle. You've got the height, the radius, and the slant height. And see how they all three make a right triangle. So sometimes you have to solve for it by using the Pythagorean theorem. So don't forget, you might have to do that to get the height. And then the last thing on the bottom, and we discussed it yesterday, it's the same idea, same thing. Remember, if a shape is oblique, it means it's kind of leaning. Now, did we change the volume formula up yesterday if it was oblique? No. And it's the same thing today. You don't change it, you use the same formula. So just because it's leaning or an oblique shape Don't change anything up, use the same formula. You do it the same way. Your height will still be imaginary and form 90 degrees with the bottom of the base or the ground level. Alright, so we're going to practice using this formula on a variety of problems on the back. Any questions on the front? Alright. First couple, we're going to find the volume. Alright, number one, we have a pyramid there. Looks like we have a square base because we have congruent symbols. So we have an 18 by 18 base here. Okay, who would like to raise their hand and tell us how we're going to find the volume of this square pyramid? We can bring up our generic formula. Who would like to get us started? What do we need to put or do or find or get? Camille?
So basically 18 times 18.
18 times 18 will give you what?
324.
And what is 324?
Wait, what?
Where do we put this now?
In for the
Right, so this is the area of that square base. So to find capital B, the square base, side times side, 18 times 18, so there's your capital B value.
Wait, is that a 1 square?
Yep.
Please?
Good catch.
Okay, and then the height would be 21 because there's the perpendicular. And then
Good. You got your straight up and down height perpendicular already in there, so 21.
which would be 6,804, and divided by 3 is 2,268. Yeah, about something. Inches.
Very good.
Something. Inches.
Inches what?
Yeah.
Volume, so it is cubic.
Alright.
Alright, good.
So,
So,
sorry.
question?
When would you multiply by the 0.3 repeating?
You don't ever really have to do that. If you divide by 3, it's taking a third.
Okay, thank you.
Multiplying by 0.3 repeating is just a way to find the third if you want to do that.
Okay.
Alright, good. So find capital B, area of the square base on the side, put that in, put your height in, and then just do the math. Multiply, divide by 3, 2268 for the volume. Alright, number 2, we have a cone. Again, we bring up our 1/3 BH generic formula. And who would like to get us started on number 2? What can we do or start figuring out or do first here? Haley?
Well, first you have to get the height because that's the slant height.
Good,
So you have to do the Pythagorean theorem.
good. We have to do Pythagorean theorem in order to write. Good, to solve for that height, because right, they give you 16 as a slant height. That's not going to do us any good for volume. So good.
So then you do 16 squared plus 6.4 squared equals c squared. And
Now look, 16 actually is your C value,
oh, really?
because that's your hypotenuse. That would be your longest side. So you want to do 6.4 squared plus whatever squared, h squared or a or b squared equals 16 squared. Make sure you guys are plugging in your sides into the correct spot. Your longest side, which in this case will be 16, is going to have to be over here by itself. I will bypass a little bit of the math here, but you should come out with about 14.7. So the height should be about 14.7. All right, so we can put that in for H. Okay, what can we focus on next, Haley?
Well then, you would do, well the base is 126.49. Because
One what?
126.42,
Alright, good, and then, yeah, how'd you get that?
6.4 to the second power, which is 40.96. And then you would multiply it by 3.94.
Alright, good, so you've got a circle base. So on the side, you gotta do pi r squared, so square your radius of 6.4, and then multiply that by 3.14. And since you already got decimals now, you might as well just use 3.14. Alright, so we get about 126, you said?
126.42.
And remember, you can get a little bit different number here if you're using like a pi button, or maybe if you rounded different when you squared 6.4. So if you didn't get exactly the 126.42, but something close to it, that's okay. Alright, then you just have to do the math. So we gotta multiply these two, then divide it by 3. But guys, the main thing here is to do Pythagorean theorem to get the height, and then you treat it like normal. Find the area of that circle base, plug your numbers in, and we should get, anybody get an approximate?
630.6.
Yeah, about in the 630 range, so 630.6 approximately. And again, we've got lots of decimals through this problem, so if you don't get exactly that, it's okay. You might have rounded differently throughout. All right, so approximately 630, 631. Okay, number 3. The number 3, we're going to use the formula, but we're going to solve for the height. So let's see what they give us. We have a triangular pyramid. They give us the volume. They give us the base here. We got to find the height. So let's plug in what we know into the formula. Here's our generic 1/3 BH. All right, in place of V, we're going to put 708. In place of capital B, they give us that direct number. So put a 240. And H is H, that's what we're solving for. All right, who can raise their hand and tell us how we're going to start solving for H here? And there's a couple different ways you can start solving from here. Sophia?
Multiply each side by 3.
Okay, you can get rid of the 1/3 if you want to start off. You can times both sides by 3 to get rid of it. That's 2124 equals 240H, and then what?
Divide by 240.
And then you can divide by 240 if you want. And it doesn't go in evenly, we'll have to round, we can round to 1 decimal place here.
8.9.
Yeah, about 8.9 will work. Now, if you didn't want to multiply both sides by 3 to start off, what's another first step you could have done? Could have done what? Okay, yeah, you could have divided, you could have flip-flopped these, divided by 240 and then times by 3. What else could you have done? So there's actually more than 2 ways. If you wanted to, you could have taken 1/3 of 240. That's 80, and then divide 80 into 708, you should still get 8.9, so several ways to solve once you plug the numbers in. All right, any questions before we hit number 4? All right. 4, a square pyramid has a height of 15, a volume of 530. Find the side length of the base. Okay, so we're working backwards with the formula again, so let's bring up the formula, plug in what we know. So V equals 1/3 BH. Alright, height is 15, we can put that in for H. The volume is 530, we can put that on the left side for V. The 1/3 is 1/3. Now look, you can, 1/3 of 15 is a nice whole number. So if you want to multiply those and call it a 5 at the beginning, you can do that if you want. Alright, now the capital B we're not given. So we're going to have to get that. And then, once we know the area of that square base, then we can easily get the side length of the square. Alright, so, well, I mean, if you want to do 1/3 of 15 is 5, now I just divide each side by 5, I guess. And that'll get you capital B right away. Yeah. Alright, now look guys, 106 is not the final answer. 106 is the area of the base, which is a square. Somebody raise their hand and tell us if 106 is the area of the square, how can we find the side length of it? Haley? Right, square root it. Don't divide by 2, square root it. Because it's the side times itself. So square root the 106. And we can round that to get what each side of the square is. Should be 10 point something, 10.3-ish. And it looks like that is in feet. Now, a couple things on the bottom. Homework problem number 20, I think they give you like a weird value for the radius, just use 1.4. And on number 16, I've given you some steps, so check that for number 16. All right, any questions on 1, 2, 3, 4? All right. Assignment for 12-5. That even set and then 32, 42.